Good afternoon, everyone. I'm going to let some more people trickle in here, and then we will go ahead and get started with today's webinar. We'll give it about one more minute, and then we will go ahead and get started. We got a hello from Rolf in the chat. Hello there. Hello to everyone. We will go ahead and get started. Good afternoon. On behalf of the National Glass Association, I am Alicia Mitchell, Senior Operations Manager, and thank you for joining us for today's Thirsty Thursday webinar. I'm joined by my colleague here, Lori Cohen, editor of Window and Door magazine, and our speaker, Ron Roberts with QLab. Before we begin, please do take note of the key NGA events coming up through the remainder of the year. The next NGA Glass Conference is taking place in Ypsilanti, Michigan, just outside of Ann Arbor. Join us at the end of September for a terrific discussion, plus a special tour of nearby Guardian Glass. Registration is open, but visit our website anytime to view the latest scheduled updates. Glass Build is taking place November 4th through 6th in Orlando, Florida. Registration is open and so many new things to see on the show floor this year. Glazing Executives Forum will be held on Tuesday, November 4th. Registration for Glass Build Trade Show is free for NGA members and just $100 otherwise. The forum does have an extra fee, so make sure to add it to your trade show pass when you sign up at glassbuildamerica.com. Lastly, there will be a live Q&A at the end of today's session, so feel free to submit any questions using that Q&A box at the bottom of your screen, and we'll try to get it to as many questions as possible. The session is being recorded and will be available on glass.org/webinars and sent in a follow-up email by tomorrow, Friday, August 22nd. With that said, I will turn it over to you, Lori.
Thank you, Alicia. My name is Laurie Cowan, editor of Window and Door, and I'm so happy to introduce today's speaker. Ron Roberts is Vice President of Sales at QLab Corporation, a global leader in weathering and corrosion testing. With more than 30 years of experience in the field, Ron has held roles in operations, sales, and management since joining QLab in 1995. He has overseen the development of major testing sites, managed international sales networks, and established QLab's presence in China. Today, he directs worldwide sales and supports a distributor network in more than 60 countries. Ron is also a frequent speaker, like today, and author of technical papers published in international trade journals. I had the pleasure of meeting Ron and his colleagues at the FGIA annual meeting earlier this year, where we got to have many conversations, some even about outdoor weather testing. I found the topic to be fascinating and jumped at Ron's offer to put a webinar together for the NGA. We're so glad you joined us today to learn more from him. Ron, take it away.
Well, thank you, Lori. I'll go ahead and take over the screen here. Thank you, everyone, for taking the time today to participate and join in this very important topic. So welcome, and I hope that all of you will find this topic to be interesting and informative. So let me replace current share. All right, can everyone see that? I hope.
Yep, you just got to put it in presentation mode.
Yep. Get my cursor out of the way here. Okay. The topic that we will be focusing on today, and as Lori mentioned, we had a very informative conversation here earlier this year in Orlando regarding the importance of doing outdoor weatherability testing. So this webinar today will focus on that topic. I just want to let everyone know that I will not be able to delve into a lot of detail today due to the time frame. But again, if any of you have any detailed questions, you're more than welcome to reach out to me and I'll be happy to address those. When we talk about weatherability testing, there are really two buckets that this falls into. One would be accelerated testing, where specimens are exposed in a laboratory in a test chamber. Those test chambers probably fall into two categories or two different types of architecture. One would be a QUV, UV fluorescent apparatus, or the second would be a xenon arc tester. These chambers control the conditions of the parameters of outdoor weathering. For example, the irradiance being light, temperature, relative humidity, water spray, etc. Outdoor tests are conducted in Arizona and Florida, and we will talk more about those two environments in a few moments. But this is where specimens of different dimensions are exposed on outdoor test racks in very large testing fields in southern Florida. Of course, due to the weather being variable, the specimens would be in an uncontrolled environment versus a controlled environment in an accelerated lab, where the samples are exposed to natural sunlight and the real world weather conditions. When we look at accelerated testing, as I said, in really most cases, you can control the irradiance or the light, heat, condensation, humidity, water spray. Outdoor, you are exposing your materials to the real world, where the samples or specimens are being exposed to natural sunlight, the variability of the temperatures from day to night and throughout the different parts of the year. Of course, condensation, humidity, and rainfall. But in addition to these, outdoor testing is going to add additional factors, weathering factors being, for example, biological attack, acid rain, acid deposits, and dirt pickup. And those are really impossible to duplicate in its entirety in an accelerated testing chamber. Some of the outdoor weathering myths are, accelerated tests are 100% repeatable. We believe that all tests, whether it be outdoor or accelerated, is going to have some form of variability. For example, accelerated testing in a lab variability can exist due to, for example, something as basic as the maintenance of the chamber, or the light sources, the lamps, or are these being replaced per the manufacturer's recommendation? Is the light source being calibrated? Is the chamber temperature and the black panel temperature in these devices, are they being calibrated per the manufacturer's recommendation? Another myth would be any degradation is good, and the wrong degradation can be misleading. For example, if an accelerated test is showing you a great deal of color change, but yet when you put your samples outdoors, you don't see a lot of color change, but you may see more physical property degradation, such as blistering or cracking or flaking, peeling. Then that degradation in the accelerated chamber is not really duplicating what is happening in the real world. A lot of companies in the world, and I've been doing this for over 40 years, is that a lot of people say, well, I don't want to do outdoor testing due to the fact that I'm not going to see any degradation for many, many years. In managing test fields in my career, I've actually seen data to be very, very useful, to where I've seen data in as little as a few months or maybe even 12 months. But in a lot of times, I've seen some very useful data where degradation is occurring in the early part of an exposure program. Weather testing data is absolute. What we mean by that is, will a single test yield perfect correlation? And the answer to that is no, that in doing a single test is not the best way to achieve perfect correlation. A test should be done several times to make sure that you're getting good repeatability from test to test. Ranked data can be powerful if correctly applied. That is true to some extent. I think what I like to focus on today, and maybe the major theme of the importance of outdoor weathering, is I'm not saying that you should just do outdoor weathering and give up on accelerated lab weathering. That's not the purpose or the focus here. What I'm really focusing on is that those of you who rely solely upon accelerated lab data in looking at formulation changes and how those behave, I really recommend looking at ranked data, where you're comparing your outdoor data to the same materials that you're testing in your accelerated lab chamber. And that's where ranked data can be quite powerful. Outdoor testing is too expensive, and we'll be discussing that more in a few moments. Why is outdoor testing sometimes often ignored? And I bring up this topic due to the fact that I remember, 40 years ago, there were a lot of different standards out there, ASTM standards, ISO standards, etc., that did specify outdoor testing in Florida and/or Arizona. And as time has progressed, a lot of these standards have been changed to where the outdoor part of the testing has been dropped and has been replaced by an accelerated lab test. And that was really, I think, maybe the reason why that occurred is time pressure. Companies want to get the results in what I call yesterday. They don't want to wait. But the key I want to focus on here is ignoring outdoor testing does represent a critical missed opportunity. Outdoor testing is an important and inexpensive complement to any accelerated lab testing that you're currently doing. It gives confidence that degradation modes are not unintentionally changing. Test reliability issues that I mentioned a few moments ago, to where maybe the maintenance of a tester is not great. The outdoor testing is going to kind of call out those experimental or reliability mistakes that we maybe see from just standard human error. It can give, as I said, rapid and realistic results, and you can establish a working correlation factor between your accelerated lab test and outdoor testing. But the critical thing is, when you do that, is you got to make sure that the same materials that you are exposing in your accelerated lab chamber, that those samples are identical to those that you do in your outdoor test in Florida and/or Arizona. The chemical composition should be exactly the same. outdoor testing is really relatively inexpensive. For somewhere between $500 to $1,000 per test per year is about the average. This would be for the exposure and then some basic evaluations, such as a visual evaluation, some color, some instrumental color, if gloss is important, a gloss reading, etc. So all in all, doing outdoor testing is highly valuable considering the cost of a test program per year. The cost of not testing, as we all know, is you can have some alarms pop up along the way to where you could have product recalls. You're going to have some unhappy customers if you introduce a product to the marketplace and then find out that things did not go in the direction that you anticipated. And then those customers may have less confidence in not only your company, but also in the results that you may provide in the future and the product. So doing the outdoor testing kind of solidifies, is your material going to last outdoors? Now let's turn our attention to, the benchmark locations for doing outdoor testing. The two are Florida and Arizona. Why Florida? Why Arizona? We will discuss that in the next slide, but there is a third environment that is very popular in the building products industry, which is a northern temperate climate, such as what we have in Ohio, to where you get these large diurnal changes in the weather and the freeze thaw that occurs with these materials. And of course, you're not able to duplicate that type of phenomena, that type of degradation in an accelerated lab chamber. And definitely it's very difficult to duplicate that in Florida or Arizona because of the environments. And then there's also, this is QLab's trade name, is a Q-Track, which is a Fresnel reflecting concentrator that tracks the sun outdoors in Arizona. And we will not go into really any detail on that today. That's an entirely different presentation, but it is an accelerated test that uses natural sunlight as the source. Why Florida? Well, people started doing testing in Florida back in the early 1930s. Actually, General Motors was one of the first companies in the world to establish an outdoor testing site in southern Florida, just south of Miami. Why? Because of very high annual UV irradiance, high temperatures, a very high time of wetness. We find when samples are exposed in Florida that the average wet time in Florida can be anywhere between, call it 12 to 18 hours per 24-hour period. So when you look at that synergistic effect between light, UV, temperature, and moisture, that is what is causing the chemical composition polymer change within these materials, then coupled with high humidity. And those of you who have been in Florida for vacation or otherwise in those months of, say, April to October, you can attest to the fact that you get a lot of sunlight, very high temperatures, and it is very, very humid. The reason why Florida is accelerated, but it's not extreme, is it has the same noon summer sun spectrum as maybe a temperate region like Michigan, or I'm actually giving this webinar from Tennessee. But that noon summer spectrum is present in Florida for really the whole year, to where you don't get that same summer spectrum in other parts of the country due to cloud cover, due to the pollution, whatever it may be, that is going to cause that spectrum to deviate. It's consistently hot, but not so hot that it is unnatural. We very rarely ever see 100-degree F days in Florida. Florida's summer is like a summer in temperate regions. Florida's winters are also like a summer in temperate regions, but it's really the same weather as the rest of the world. But Florida just gets more of it. What I mean by more of it is we see that really on a consistent basis, 365 days of the year. Arizona, it actually has even higher UV than Florida. Arizona averages at least 20% more annual UV than Florida. The temperature in Florida is going to average, again, not high, but an average of at least 10 to 12 degrees Celsius hotter than Florida. But then in Arizona, especially in the the January to April months and October, November in Arizona, is you have these high temperature swings to where it can be very, very hot during the day, but due to the fact that you're sitting on a desert floor, that desert floor can get very, very cool in the evening. And so you get this large thermal cycling effect that occurs in Arizona that you don't see in Florida. And then Arizona is a very arid region of the country where we see very little relative humidity, and the annual rainfall is about only 5 inches per year. So this is kind of a summary of the parameters to where if we look at Florida, and I'm not going to read down through each one of these sets of information, but I just want to call out, as I said, Arizona is about 20% higher on an annual basis in reference to annual solar energy. When you look at TUV being total ultraviolet in the wavelength region of 295 to 385 nanometers, you can see quite a difference between Florida and Arizona. And then, as I said, the summer average max temperature is quite different. In starting our site in Arizona 30 some odd years ago, I spent a lot of time outdoors in Arizona, and I can attest that it gets very, very hot. And for those of you who have maybe vacationed in the summertime in Arizona, you can verify that those temperatures during the day in Arizona are very, very warm. Not uncommon to see temperatures in the summertime to be consistently between 115, 120 degrees Fahrenheit. I'm going to skip over this because we've kind of already discussed that. But the next part of the presentation kind of focuses on the different types of exposures that are available when doing outdoor weathering. So when we talk about outdoor weathering, it's just not putting samples out and thinking that you're going to get good results or reliable results. We have to consider exposure angle, whether the samples or the specimens are backed. And then is it a direct exposure? And for, I think, mostly everyone on this call, it would be your materials would be exposed directly to sunlight versus that third bullet being under glass, where samples would be exposed under a 3 millimeter single strength window glass to simulate sunlight coming through window glass. So we're not going to spend a lot of time on that one due to the fact that if my assumption's correct, it would be mainly materials that you're manufacturing at your facilities would be exposed to direct sunlight. Then there's also black box, mildew enhanced, salt accelerated, and then testing the entire product. So we kind of look at the different exposure angles that are the most common in Florida and Arizona. 45 degree, again, is going to be the most popular. It's been used for about 100 years now in putting samples, and that's kind of the default exposure angle. And again, being in the northern hemisphere here, when we say 45, we mean 45 degrees south, horizontal or south from horizontal. And again, it's the most commonly used outdoor exposure angle. Vertical or 90 degree, again, is great for window profiles, wood siding, architectural coatings. But I often, as I've worked with customers through my career, if it's a new material, I always recommend, if you don't have any data on it, I always recommend that you expose it in its end use application, meaning if it's going to be in a vertical orientation, expose your samples in Florida and or Arizona in a vertical position. But maybe due to the fact that outdoor weathering is not all that expensive, maybe put a duplicate set of materials on a 45-degree rack and see the difference in the degradation. Roughly, the degradation is going to be about twice as fast on a 45-degree rack versus 90. But again, that's a general comment. Again, it's going to depend upon the material formulation, you know, the additives, the resins, what have you, that is in that material. 5-degree south is very, very common in the automotive area. Roofing materials, very, very common for that. And then horizontal, great for testing 3D parts, also doing outdoor roofing, EPDMs, etc. A very, very popular angle. And both the 5-degree and the horizontal in Florida is going to provide you a lot of increased wet time. As I mentioned before, that time of wetness that we see in Florida in a 24-hour period, those samples on a 5-degree or horizontal rack, because they're flatter, the moisture is going to sit on those samples for a longer period of time. You will see an increased wet time. And if those materials are susceptible to degradation when exposed to moisture, you will see that more so on the flatter angles of exposure, 5-degree horizontal versus 45 or 90. This is just an example of a 45-degree rack that is very, very common in Florida and or Arizona. A 90-degree exposure angle. 5-degree, again, very, very popular for automotive paints. And then horizontal, 0-degree. As you can see here, some headlight, taillight assemblies. And we'll be discussing next now the backing. There are 3 backing techniques that are used. The main standard, for those of you who may be interested, the main standard for outdoor weathering is ASTM G7. That gives you a very good understanding of how outdoor weathering should be carried out in Florida and or Arizona. Open backed exposure is typically used for rigid specimens, painted metal, plastic lenses, etc. You've heard me comment a couple of times so far in this webinar is we always want you to be exposing your materials outdoors in Florida or Arizona as they would be seen in an end-use application. And so if your materials are not going to be against a backing in its end-use application, then you should expose them open-backed. If your materials are against a backing of some type, say a plywood, etc., then you also want to simulate that same environment that you're seeing in that end-use application by having the test site put your samples out against a plywood-backed exposure. As you would expect, vinyl siding, roofing, any type of material where that material is seen in an end-use application against a backing, that is the preferred backing to be used in outdoor weathering. Here is an example of an open back exposure rack where the samples are not only open to the environment on the front, but in that right-hand photo, you can see that there's no backing, that the samples are open also, even though it's not the test space of the sample. This comes into play when it comes to temperature, and that is that an open backed rack is going to be cooler on an annual basis versus a backed exposure due to the fact that you get this backside convective cooling. So samples in an open back versus a backed, depending upon the time of year, could be cooler, the open-backed specimens to be cooler by as much as anywhere between 10 to 20 degrees C versus the same sample on a backed exposure rack. So my point here is it's really, really important when doing outdoor weathering to make sure you pick the right backing to be used for your particular material. A mesh backing it duplicates an open backed rack. There's no difference in the cooling effects of this mesh. The only reason why we use the mesh backing is it provides a really, really good support if you're looking at flexible materials. To where if you can imagine, if you try and put a flexible material into a exposure test rack, over time that those samples could droop, they could fall out, they could become concave, they could become rigid, to where then if you're trying to do any type of evaluations such as color, gloss, anything that's instrumental, if that sample isn't perfectly flat, then we have issues in getting really, really true and reliable instrumental measurements. So that's really the reason why we use the mesh backing. Here is an example of a plywood backed. Again, it's just usually a 5/8 inch or 3/4 inch plywood backing that is used in Arizona and Florida for any backed specimens. Under glass is just, again, using 3mm single strength window glass. And again, for those of you on this call that may be interested in this type of exposure, please let me know and we can discuss it in more detail. Here is automotive interior testing, seat fabrics, headliner materials, IP panels, your instrument panels. These are all very popular for doing under glass exposures using a black box. The reason why the black box is used is it's going to achieve higher temperatures than a backed or open backed rack by as much as 10 to 15 degrees C higher. The interior of the black box is not painted black, it's only the exterior. But it's important to make sure that when doing black box testing that the top of the box is completely sealed to not allow for any type of air circulation, that it's really more or less not a true sealed box, but it's about as sealed as you can get it. This would be more representative of a direct exposure with a black box, again, making sure that the samples are, if there's not enough samples to fill out all of the areas in the black box, we use black blanks, again, to make sure that that top of that box is completely sealed to make sure that the test temperatures are elevated. Then some maybe not so common type of exposures that are done in Florida is a mildew enhanced exposure. There's an area of our field in Florida to where samples can be put facing north, either at 90 degree or 45. And with the vegetation close by, it creates a longer time of wetness. The spores that come from that vegetation create the fungus, the mildew, etc., that you would maybe see in an end-use application of your material. So not a real common type of exposure, but it is available. There is also an ASTM standard, D6675, for doing salt testing outdoors. Many of you who may be familiar with accelerated lab corrosion testing, there is also this ASTM standard to where you can spray a 5% salt solution twice per week on the specimens. And the nice thing about this type of testing is you're not only getting the corrosion from the salt solution, but you're also exposing your materials to direct sunlight. So it's that synergistic effect between the salt and the weathering. Whole product exposures. I'm a big proponent of this. whether it be a car or a window or a door, whatever it may be, instead of maybe just exposing small specimens. I've seen over my career that customers that will expose the entire product, whether it be a skylight, a sliding glass door, a window profile, whatever it may be, you can oftentimes see degradation criteria that occurs on that whole component where you do not see it on individual smaller specimens that could be 6 inches by 12 inches, 150 millimeter by 300 millimeter, because of the stress strain relationships that are occurring between these materials and how these components interact with the weathering process on a day-to-day basis. So I've seen some dramatic effects of that whole component in how it changes versus the same change that you see on a single specimen. Let's turn our attention as we try and conclude here and go into a Q&A is I want to discuss a little bit about how do we set up the proper outdoor weathering testing program. I always recommend is, again, you don't have to test in Arizona and Florida unless you feel that those two environments are representative of how your material will be seen in an end-use application. For example, I know this doesn't pertain to really any of you on this call, but we don't see, for example, a lot of people testing automotive coatings in Arizona. Why? Because it's very arid, and automotive coatings really last for many, many years. As you drive around Phoenix, you can see cars look pretty darn good many, many years after they're purchased, 10, 15 years, because there's no moisture that's causing that synergistic effect and causing that polymer degradation, that breakdown of the resins, the pigments, etc. But if you feel like temperature is a key in your testing program, then I would highly recommend testing in Arizona. Why do testing every year? Well, you want to develop a library of data. You want to make sure that maybe any formulation changes that you're doing, whether they be minor or major formulation changes, that you're developing a library of data to make sure that you remain confident that the testing you're doing outdoors is representative of any type of degradation that could occur in an end-use application. I always recommend that you compare old formulations to new. I often tell customers, test your competitors' materials alongside your own materials. Find out how your material is doing compared to a competitor. The value of test data increases over time. I call it, it's like compound interest. Develop a library of test data comparing the outdoor data to the laboratory testing data. Determine, is your outdoor data, are you getting good correlation to what you're seeing outdoors? If you aren't, and this is kind of a side comment, is that don't blame the architecture of the test if you're not seeing maybe the degradation that you see outdoors in either a QUV or a xenon arc test. It could be that the lamp type that you're using in a QUV, whether you're maybe using UVB 313s and you should be using UVA 340s, or in the optical filter that you're using in a xenon arc, maybe that is not the proper optical filter. Maybe the irradiance set point or the black panel temperature or the relative humidity, maybe those set points are not representative of what you need. Also, going back, if you're not maintaining your tester, if it's not being calibrated, if you're not changing your light sources, then that can all contribute to getting false information from your accelerated lab test. Best practices for outdoor weathering is begin testing as soon as possible. Again, because it's outdoor testing, I often tell customers, start that test first before you ever start your accelerated lab test, because then that's going to take the longer time period to get to the endpoint, but yet you can get those results much sooner if you do not procrastinate. Use a balance of a mix of specimens. What I mean by that is if you have control specimens, and what I mean by a control specimen is you have outdoor data on it, or you have long-term weatherability data on that material, test that alongside any new formulations that you want to test. And then don't always test all good materials. Have a mix of what I call kind of the good, the bad, the ugly, and get a good mix to where you can see the representative changes that are occurring within those specimen types. We always recommend using at least 3 replicates to, again, try and enhance repeatability, reproducibility from test to test, to where if there was any slight changes in the way that these materials were manufactured, testing just one specimen could yield poor data due to the fact that maybe it wasn't that material wasn't made correctly. So sometimes duplicate at least 3 different replicates. This is a big one for me. When you do outdoor weathering or even an accelerated lab test, evaluate regularly and often. Do not put samples in an outdoor test or an accelerated lab test and just evaluate those at the end of the test. You haven't really learned anything if you do that. The reason why is if a material fails, well, if you haven't evaluated along the timeline, you really don't know when that material failed. Did it fail at 3 months? Did it fail, the day after you put it out on exposure in Arizona and Florida? So I always recommend at least 5 intervals per test. If somebody is running a 5-year outdoor test, I often recommend doing evaluations every 6 months. If you're not seeing a lot of change after a couple of years, maybe you can call your test lab and have them change the evaluations to an annual. But again, having frequent evaluations is powerful data. And we've already mentioned this, use a control or reference specimen against any new material formulations that you're testing. We always recommend, to get any type of good data, a minimum exposure period would be anywhere between 12 to 24 months. Anything less than that is probably not going to yield any useful information. And then perform testing to failure. You have to determine as a manufacturer what is failure. Is it physical property degradation? Is it color change? Is it both? You have to, your parameters of when failure occurs, and we always recommend that you test it till failure. I've seen in my tenure in the weathering industry that things can start going south on, say, a material pretty quickly. Another material may look great over that same period of time, but yet if that testing continues, that good material that maybe looked great after 12 months ended up after 36 months or 60 months to be the poorest performer. So always recommend testing to failure. Just the experimental design of a test is every specimen type should be in every test. Every material that you manufacture should be part of that testing program. Use equal number of specimens in each test. What I mean by that, I wasn't clear maybe on that, is if you're doing a test in an accelerated lab test, make sure that the specimens that you're doing in your accelerated lab are the same materials as you're putting outdoors. Use regular exposure periods, except it's okay to schedule more evaluations in the early period to catch any early failures. And then use the same evaluation techniques throughout. Don't change midstream. Make sure that what you start with on your evaluations, you continue with. Make sure that, if you're doing instrumental color, that you're not changing manufacturers of the color instrument midstream, because that could introduce a variable. Same for gloss. So just be sure that you carry out those evaluation techniques with the same instrumentation, the same evaluations throughout the test. Replicates, the more specimens, the better. It adds to better data analysis. It gives you a better library of information as you test more specimens. And again, as we said earlier, at least 3 replicate allows mean and standard deviation calculations. More specimens give higher confidence that small differences in test results are truly meaningful. When we say a reference material or a control, those 2 terms are kind of used synonymously, but always use a material, if you can, of known performance. I mentioned this earlier, to compare that known material compared to a new formulation. Is your new formulation worse than, equal to, or better than your known control? I think we've said all of this. Yeah, I think we can just end with that. Repeat test, the first step in writing maybe an internal test standard, is to prove that it can be repeated. So again, as we said before, carrying out an accelerated lab test or an outdoor test one time, that may not prove to be the fact that can you get the same results twice in a row. So we always recommend repeating weatherability testing to have a larger library of data and reduce that variability that you may see from test to test. Some materials do require a shorter outdoor exposure. This is really not pertinent to probably any of you on this call. Could be in the food and beverage industry, cosmetics, the personal care, we call it the FMCG, fast moving consumer good industry, optical lenses. But again, it really doesn't matter. We always recommend that you test to failure. Test durations for more durable materials, such as your windows and doors, as you all know, roofing materials, sealants, etc., could be 1 up to 50 years of outdoor exposure, depending upon maybe the warranty that you're carrying to the consumer on that product. As a summary, example test program would be, again, this could be true for also Arizona, but pick your angle of exposure that is most relevant. Determine what your test duration is. Now, we at QLab in Arizona and Florida, if you start out and if you tell us the duration of a test, but you find out that you see an early failure, if you want some of your materials returned early, we can do that. And of course, you're not charged for any of that. Your testing program cost would be reduced due to the fact that the number of materials on exposure has decreased. Measure at least maybe every 3 months on your evaluations, at least to start. Maybe you can extend that a little bit as you get more confident in the data that you're getting. And then we always recommend, if you can, if you're exposing small specimens, a 100 by 300 millimeter or 150 by 300 millimeter panels are usually ideal, especially for evaluations, etc. Again, try and duplicate that same program in an accelerated test, whether it be a xenon arc or a QUV fluorescent. And really the parameters you would want to try and do those evaluations often in your accelerated test and compare the evaluation period, whether it be 500 hours, 1,000 hours, how do those evaluations compare to what you're seeing outdoors? And you always want to make sure that you're doing, again, those evaluations frequently enough to where you're catching any changes that may be occurring. So, conclusion, accelerated testing is a great way to get fast weathering results. Outdoor weathering complements and verifies accelerated testing. The outdoor testing, it's often overlooked, despite being inexpensive, fast, and it's very easy to implement. And again, it increases the confidence in your company to make sure that you're correlating to what you're seeing in the real world. Thank you for your time. I'll stop sharing my screen and we can go into a Q&A. Thank you very much.
Thank you so much for that great presentation, Ron.
You're
I know
welcome.
I had a lot of I know I had a lot of questions that I jotted down throughout, and you ended up answering them along the way. And I suspect that may have happened with quite a few of our attendees too, because we don't have any questions in the Q&A box. If any attendees today end up having any questions, I would encourage you to reach out to Ron directly, or you could also reach out to us at the NGA, and we'd be happy to connect you to chat further about this topic.
Yeah, again, I had to go pretty quick today because I wanted to keep it within the 1 hour with Q&A. But if anyone has questions pertaining to their own product, any maybe confusion, what have you, then I'd be more than happy to have a one-to-one conversation with that individual.
Okay.
We
It looks
actually just had one question pop in, if we have time, from Chris B. He said I am interested in testing multiple hydrophobic coatings on pyrolitic, glass. What is the protocol for testing coatings on glass?
That is Chris, thank you for that question. I think what I'd like to do, because that is going to require somewhat of a detailed response, let me give you my email address and let's have a conversation either by phone or email to address your question. I don't want to dismiss it here by giving a short answer. So my email address is RROBERTS. So it's my first initial, Ron, and last is Roberts. So it's rroberts@q-lab.com. Again, rroberts@q-lab.com. You got it. Thank you, Lori.
Perfect.
But again, thank you for that question, and we can definitely address that offline.
Awesome. Well, thank you so much for your time. Thank you everyone for joining us today. As a reminder, this webinar is recorded and will be available tomorrow on glass.org/webinars and sent to everyone's email in the follow-up email. Also take note of our upcoming webinar on September 11th at 2 p.m. Eastern Time, Safe by Design, Security Glazing and High Performance Glass in Educational Facilities. Thank you all, and I hope you have a great rest of your day.
Thank you very much, everyone. Bye-bye.